Dear students, now we are going to have to discuss the basic concepts of group theory. Before entering to the group theory, we must have the basic knowledge of sets. What do you mean by a set? Set is a collection of well-defined objects. If we are saying student, either he or she should belongs to a learner from a kindergarten to research scholar. They are classified into primary school, kindergarten, high school, higher secondary school, college student, undergraduate student, and postgraduate student. Like this manner, we have to separate and define the student in the manner. The persons who are studying courses from open resources or from distance learning program, that is correspondent course, are also said to be students. In convention, we will say a student is a person who wants to study from a teacher by attending the classes regularly in an education institution. Either it may be a kindergarten to higher education institutions. So, basically, set is a collection of well-defined objects. Next one is binary operation. What do you mean by a binary operation? Operation that means that do something between any two elements of a set. In mathematically speaking, we will say binary operation means either it may be an addition between any two elements, multiplication, subtraction, division, power of a number, squaring that number, taking log of that number. Likewise, we can do any operation between any two elements. Okay. So, to create a group, we must have the basic thing that two things. One is a non-empty set. Another one is a binary operation. So, a non-empty set together with the binary operation is said to be a group. It has to satisfy the following condition. What are they? See, let G be any non-empty set. Star be a binary operation if we say G comma star is a group only when consider for all elements A, B and C that belongs to G must satisfy the following operations, axioms. What are they? First one is closure axiom. Any two elements that belonging to the set G is taken and having the binary operation star between them, the resultant element also must belongs to the set G. If two elements are taken from the set G and binary operation between the two element was made, and then we have a resultant element that is also belonging to the set G. This property is called closure property. Next one is associative property or associative axiom. Let A, B and C be any three elements that belongs to G, then A star B star C equals A star B star C. That means A, B, C, B, any three elements that belongs to the set G. First we have to operate A and B, and then the resultant was operated with C. That value equals operation between B and C. The resultant makes another operation with A. This is called associativity or associative property or associative axiom. Next one, let E be an element that belongs to G such that E star A is equal to A star E is equal to A. That means existence of identity. Let A be any element that belongs to the set G and E be an element in G in which either E is operated with A or A is operated with E. The resultant is A. Such a manner, there should be an element. That element is called identity element. This particular property is known as identity, existence of identity element. Next, inverse, existence of inverse. Let A be any element that belongs to the set G in which A dash or A inverse be another element that belongs to the set G, especially A star A inverse is equal to A inverse star A is equal to E. That means the identity element. A dash or A inverse be an element that is an inverse element of A. Either A is operated with its inverse or its inverse is operated with A, results the identity element E in G. If the four properties or axioms are satisfied by G with respect to star, then we will say G comma star is a group. If just two properties are satisfied, closure and associativity, then we will say it is a semi-group. Suppose three properties are satisfied, that means closure, associative and identity, then we will say it is a monoid. All the four properties, that is closure, associative, identity and inverse, are all satisfied, then we will say it is a group. Let G be any non-empty set with respect to the binary operation satisfies all the four axioms, then we will say it is a group. Let G comma star be a group. It satisfies the commutative property. That means commute between two elements A and B. That means A is operated with B, value equals B is operated with A. This property is known as commutativity or commutative property. Then we will say G comma star is an abelian group. Okay, now let us think about the set of all natural numbers and well-known property, that is a well-known operation. Addition is a binary operation. If addition of any two natural numbers results another natural number. Similarly, addition of any three natural numbers also results another natural number. So first two axioms are clear with respect to addition. Let us think about the third one. A natural number is added with a single number results the same number. The value is 0. But the number 0 does not belongs to the set of all natural numbers. So natural numbers with respect to addition is a semi-group since it has no identity element, that is additive identity element is 0. If 0 is added with any other element, results 0. Results the same number. But the number 0 does not belongs to the natural numbers. Next one, If this one and only handicap with respect to the natural numbers identity element is existence of identity element, that is 0. If natural numbers in addition with added with the number 0, we will have whole numbers W. So whole numbers having set of all whole numbers with respect to addition having identity element. Since natural numbers is a subset of whole numbers, if the what are all the properties held by natural numbers is also held by whole numbers. Okay. Likely we will think about existence of inverse. Let 3 be a number added with 3 results 0. That particular value is what? That particular value is